Problem 4. A rectangular loop with a sliding conductor of length L is placed in a uniform magnetic field perpendicular to the plane of the loop. Resistance of the connector is R. So resistance of this moving connector is R. Find the current through the conductor when it is moved at a constant speed V to the right. So this is a rectangular loop. The resistance of the left side is R1. Resistance of the right side is R2. The connector is moved like this. Therefore, a motional EMF E equal to BLV will be generated in the connector. So the connector is now a source of EMF. Applying Fleming's left-hand rule, you see that the current in the conductor. So you take magnetic field into the paper, and this is the direction. So current flows upward. So this is the direction of current. So we can consider this rod now as a battery of internal resistance capital R. Resistance of the connector is given as R. So you can take it as a battery source of internal resistance R with these two resistances in parallel. So we can depict like this. This is the internal resistance, EMF of the cell, and the two external resistances in parallel. Okay, so the current direction is like this. So what is R effective? R effective is R1 R2 by R1 plus R2 plus R, because these two external resistance come in parallel and the same current will flow through them. Therefore, effective resistance in the circuit is R1 R2 by R1 plus R2 plus R. Like this is like the internal resistance of the battery with EMF E. Simplifying this, we get R1 R2 plus R into R1 plus R2 divided by R1 plus R2. So I equal to E by R effective. What is E? BLV divided by this value. So substitute R effective. Substituting R effective from the above formula, we get R1 R2 plus R1 plus R into R1 plus R2. The denominator R1 plus R2 will go to the numerator. Now compare all the options given. We find that the correct option is A.